Hello there, this is Dizzy, and it's time to play some Minecraft. So this is the sort of second NuclearCraft video I've done, and I realized after doing the one last night that I was thinking about some stuff wrong. So kind of want to walk you through what I've figured out, or what I think I'm figuring out, and sort of bring you along for the ride. So let's go ahead and get started. Let's see, there we go. So I have burned so far through, oh, that's energy stored. Wait, why? Oh, interesting. Oh, darn. All right. So anyway, I have burned through one TBU tablet, so the thorium, whatever it is, and I now have that depleted fuel. But I also realized last night that I have a ton of uranium on hand, and you can use uranium to burn in the reactor as well. So it's a little bit more work though. So I think that's probably why, figuring that out could take a while. So what I did was I took some uranium. I got 547. You take the uranium, you put it through a pulverizer, and that gives you uranium grit. Let's see if I have any in here. I don't. So let's just do it real quick. I'll just show you the process. So we take some uranium. I'm going to put it into my pulverizer. Right there. Apparently I took two of them, but that's fine. And this is going to give us uranium grit, right? We'll have 4 altogether. And that went back into the system, so let's get that out real quick. And the processing step is the same as the thorium, right? Like we just have to put it into the isotope separator to sort of break it down, because you can't just burn uranium directly. And I'm pretty sure actually none of the fuels you can work that way. So you always have to have your isotope separator. You can see I put a bunch of upgrades in to speed things up. So we just put the uranium grit in there. And what we should get is uranium-238 and 235, right? And so we get a tiny clump of each of them. So the trick with uranium is knowing how to assemble it, because there's a mixture that you have to have between the 238 and the 235 to actually do anything. So you can see that I already did some other uranium. So I'm going to just go ahead and put these in here, and we're going to have to assemble this now. Now for the depleted TBU fuel, what I did was I built a fuel reprocessor, and I'm going to put it in here and see what happens. And we'll go from there. So let's see, this guy is almost done. And we're filling up. Yeah, I mean, we're exceeding our energy demands right now, which is great. Okay, so that's good. The fuel oh, this is almost done. Let's see what we get out of it. Okay, so we got 233, which is good. We got 235. We got some Neptunium, which is going to be important because I think that'll lead the road to platinum. So great. So we've got a bunch of byproducts that we're going to use for making other fuels. But I think for this video, we are going to focus on the uranium. So I believe that what you can do with this 235 is that we can make sort of this grid. Let's just even it all out. All right, so that gives us 3 235s. Is there any more 235, or was that it? No, it's just 233. I don't know how to use that one yet. And then 238s that we got from the uranium. Put that in there, balance that out. Oh. Okay. I worried myself there for a minute. All right, so I believe what you can do, you don't want a depleted uranium block. We can make this. So we have 7 238s and 1 235, and this should give us low enriched uranium-235 fuel. So basically the active part is the 235, and then I don't know, there's nuclear physics involved, but this is the LEU, so low enriched uranium. If we had more uranium-235, there's another mixture where you can use 4 of those and 4 of 238, and that gives you high enriched, but we don't have enough 235 to do that yet. I suppose we could just I think how many more would we have to do? I think 9 more to get enough. But let's just start with the LEU 235. And to contrast this a little bit, let's look at the thorium, the TBU. So TBU runs for 120 minutes at 60 RF a tick and a heat of 18. And then LEU 235, let's see, LEU 235, is that what that is? Yeah. LEU 235 runs at 60 minutes, so half the time at double the RF and more than double the heat gen, I believe. So it basically burns sort of faster and hotter, if you will. So the interesting thing about this is, let's go back over to our reactor, which should be out of fuel, which is perfect. So we've got another depleted one. And let's make sure it's off, because we're going to put this new fuel in there. Now, it'll be, yeah, that's what I thought. So that doubled our RF a tick, but we're now 750 heat per tick over, which means we don't have nearly enough cooling anymore. Those redstone cells are not sufficient for this. So, I mean, what you can do, famous last words, you can see the heat building. So I turned it on. It's generating just a ton of RF right now. I don't know why it's not filling that up, but it's also heating up pretty good. So it's, yeah, it's netting at 750. So we're going to turn this off. We don't want that, and it'll naturally cool. Looks like this RF is drained. Oh, I know what's happening. It's because, there we go. All right, so that, right. So I had problems overnight because this energy cell is totally drained because our system's just not keeping up, even just keeping this AE system alive. Okay, so we don't have nearly enough heat or heat dissipation. We're 750 over. Now, something I wanted to try, and you can try it with me, is active cooling. So what we've used so far, let's just open this up real quick. What we've used so far is passive cooling, which basically means that these blocks provide sort of ongoing cooling and a certain amount, and there's certain rules. Now, there is another kind of cooling for fission called active cooling, where you're pumping a liquid in, a liquid like this, to actively cool it. And I don't know sort of what the stats are, but I've heard that they're pretty significantly higher. Like, I've heard they're like 5 times as high as the passive cooling, but it consumes whatever you pump in. So we're going to start with water, because that's the only renewable thing I've got right now. And so what we want to build is a active cooler, I think it is. Yeah, which actually looks pretty simple. And so we're going to need to pump water into this. I think it consumes like 2 buckets a tick or something. It's a lot of water. I don't even know that we can generate enough water. So we're also going to need a buffer, I believe, is what it's called. And this is, we can put it in the shell, and then what that does is it can pump stuff in or out. So let's see here. A couple of solenoids, a hopper, buckets. Okay, so let's go ahead and go craft that stuff up. Well, I'll tell you what, let me do this off camera. I'm going to craft up a buffer, and I'm going to craft up a couple of coolers. Now, on the water front, why I think water is going to do the trick here. So water generates 60 heat, or can cool 60 heat per tick right now passively. Now, if the numbers I've read are correct, that an active cooler can do 5 times the passive cooler, 5 times 60 will give us 300 heat per tick we can dissipate. And right now we're over by, case is incomplete. I thought it was 400 or something like that. Let's check here. We're over by 750. So if we had 3 coolers, that might be enough. Maybe 1 more redstone, and then 3 coolers, 3 active coolers. Wait, 60 times 5 times 3. Yeah, that should be more than enough. All right, so I'm going to go craft that stuff, and then we'll come back and put it in and try not to blow ourselves up. Okay, back in a few. All right, I am back. I think we've got everything we need now. I crafted 3 active fluid coolers, a buffer so we can pump stuff in or out, a tank, which we're going to use as a sort of liquid buffer for visual inspection. I'll show you what we do by that. Crafter, which is not really necessary for that, and a sink, which I know it's a little cheaty, but it generates, I think, enough water for what we need. I'll replace it with an aqueous accumulator when I get a chance, but that was the easiest thing to make right now. So let's go ahead and figure this out here. Now the active coolers, let's see, the requirements for each fluid type are the same as the passive counterparts. So if we look at coolers and we're using water, what are the rules? Must touch 1 reactor cell or 1 active moderator block. So easy enough. Okay, so let's see here. Let's break this thing open. I really need to make that door to get in and out of this thing. So let's see. These redstones have to touch a cell and a wall, I believe, right? No, just a cell. Okay. All right, so how are we going to do this? So the active coolers have to be touching a cell. They also have to have water pumped into them. So maybe what we do is we put them like this. And then because they actually have to have the water pumped in. So then we go ahead and do this. And then we're going to put the buffer right there. And then we run the fluid duct over to that. And just for cleanness, we'll do that. I don't know if we have to explicitly pump out. I guess we will find out. And now for the redstone, we got 5 of them. They have to touch a reactor cell. So we'll put 2 here, 1 there, 1 there, and 1 there. I might just wind up making another one of those. And then let's just close this up real quick. Okay, so I think to see the heat dissipation results, we actually have to pump stuff in. We have to pump some water in so it can figure it out. So I'm going to put the sink right there. Kitchen sink powered fission reactor. This is awesome. I'm actually going to... Actually, let's do something here. Let's not put the sink there. So what I want to do is I want to have some sort of visual indicator as to whether or not the sink's going to be able to keep up. We don't have to have it there all the time, but while we're doing this first design, we need it. So what I'm going to do is I'm going to put that there. I'm going to put that like that. And then I'm going to run this down here like that and into the sink. So what'll happen is the sink, if everything's cooling and keeping up, the sink will be able to tell that the sink's keeping up because that buffer, this tank buffer will be full. So let's put some servos on this. Let's see when you want on there, I believe. Make sure it's active. And great, that's filling up the water. And then we're going to knock that so that it drains, and it is draining, which means it's going into the cooler. So we should be able to come over here. Okay, so that's, notice we're still 750 over, which means that it's filling into the buffer, but it's not coming out the other side. I was afraid of that. So let's put another servo in right here. Set that one to active. And let's put this back together. And oh, that's better. Okay, so that gave us 300 heat per tick. So that cut it in half. Because it was 720, I believe. We have 3 of them. 180. So basically the active coolers, I guess, are about double. Is what I'm taking away from that. Because without them, so if it's 120 times 3, that's 360, which offsets the 720. Yeah, that's about right. Okay, so it's only twice as cool. That's not really as much as I was hoping for. Liquid quartz would be really expensive. Liquid tin would be really expensive. There's not... Well, this is something to think about. We might be able to get glowstone going in the future. Liquid glowstone, which would be pretty cool. But I think we're a little ways off from that. Yeah, I mean, a lot of this stuff's just going to be really hard to make. I don't know what would it take to make liquid helium, I wonder. That's going to be one I have to look into, because that might be the way to go. But we cut it in half, so we can at least run this longer now. And the heat's not building as fast. So we're now cooling it much more efficiently. So now that's, yeah, so that's interesting. It looks like the sink is keeping up, though. So, I mean, one possibility here is that we could add more water coolers. I think if we added 3 more, it would work. So let's just make 3 more coolers and stick them in there. Actually, I'm going to make... I've already got an empty passive cooler, so I'm going to make 1 more of those. I'm going to make 3 more of these. Let's see. And then I'm going to make a redstone passive cooler. 1 more just for symmetry. Okay. And between that and the other 2 coolers, I think we'll have enough. It looks like the sink can keep up. So let's see here. So that can go there. Oh, but where are these other coolers going to go? All right, we're going to have to change this whole thing up. So what we're going to have to do is move the cells more into the middle, because we can't access them easily enough right now. So we're going to move these cells, which is going to complicate. We're going to have to move the buffer too, unfortunately. All right, so what we're going to do is move the cells into the middle so that we have more sides to work with. I think that will give us more sides, right? Yeah. And then what we can do is run... Yeah, so we'll run the other 3 there, then we'll run the buffer right here in the back. It's going to be a pain, though. Maybe the buffer on the top? Yeah, that'll work better. All right, so we'll put the buffer up there. That'll cool those. Then we'll run the redstone coolers on the other side, like that. And so let's move the buffer. Just dismantle all this. Doop, 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 doop. I can't get over the sink part. It's just kind of funny. All right, so let's put this here. I don't have any scaffolding. What happened to all my scaffolding? All right, let's go make some scaffolding. To remember what the recipe is. There we go. All right, get some scaffolds. And how are our coolers coming? There we go. There's our other 3. Okay, great. So let's put the other 3 in and wire everything up. Let's see here. Okay, so now we've got those 3. And now what we're going to do is run like that. We're going to put the buffer up here, like so. And then we're going to reinstall the servo and activate it. All right, so now those 6 coolers should be cooling it, and then the redstone on the other side. And then we'll do that. And then we'll just put the scaffolding up here and move our sink and pump. Now we're going to want to be able to see it, though, is the problem. So how are we going to do this? I think what we'll do is we'll put... I'm just going to put that there. I'm going to put this here. I wonder if that'll keep that full just by being side by side. Let's find out. No, it won't. All right, so we got to pump into it. So we'll just pump over. Yeah, and so it's filling up those coolers right now. I'm kind of curious if it's going to be able to keep up. It might not be able to. All right, so they're all full. Let's go see what we did to our heat numbers here. Yeah, now we're negative 240. Great. So we can now safely run a low enriched uranium. So we went from a thorium to now low enriched uranium. So let's go ahead and run that. And let's go check on this tank and make sure it's staying full. It looks like it is. So that sink will do the trick. Now, NuclearCraft does come with self-contained water blocks. Can't remember what they're called. Infinite water source. So there's a 10 millibucket, 80 millibucket, and 640. And they're pretty easy to make. They're just some plates, a bucket of water, and 10. So I could probably replace the sink with the dense one, and that would be fine. But this is working for now, and our it's cooling, so it's keeping up. And so I think the plan now is that from this low enriched uranium, we should get something else that we can reprocess again. At least that's the plan. So let me go ahead and process that fuel. And then we can sort of work our way up. What I haven't figured out yet is how do you, like, what's the optimal chain here? Because, you know, you don't want to be redesigning a reactor, and each thing only outputs a certain amount of the next thing. So I need to work out the math and understand sort of how would you chain these things together in a meaningful way, because I don't understand that part yet at all. But we have sort of the beginnings of a much more powerful reactor. We went from what? I think we were generating like 820 before, now we're generating 1680. And, you know, again, we had to do a little bit of work to get it cooled, but it worked without too much trouble. So active water coolers are pretty cool. They make a pretty big difference. They're fairly cheap to make. You just need a water source. And then the redstone obviously are also doing pretty good. But, you know, let's see, what is our heat generation at this point? So we're cooling, it needs about 1200 heat per tick to keep this thing cool. Previously it was only like 200 or 300, I believe. So, you know, this thing runs a lot hotter, but it's now safe to run for as long as we want. So I think I'm going to wrap it up there. I haven't quite figured out what the next step is yet. I need to do some research. I think probably I need to work out the math for all the different kinds of fuels and stuff and figure out what makes sense. But our little nuclear reactor project's coming along. Really need to get rid of that sink on top. But I'll keep you all in the loop as I discover new things. Thanks, and take it easy.